This is Group 9's Thermodynamics Steam Engine project. This is our steam engine that we designed based on an existing model of a compressed air Wankel rotary engine. Wankel engines generate their power by making 3 power strokes per cycle, with each edge of the trochoid rotor completing a 4-stroke Otto cycle during each revolution. The steam engine we designed was based off an existing model of a compressed air Wankel rotary engine. We created our engine with a 3D printer. The print took 8 hours total, however, we had to reprint the housing, which took 5 hours. Using the 3D printer is what ultimately led us to many of the challenges that we faced during this project. While the Wankel engine can be made using 3 parts, our compressed air Wankel engine consists of 5 parts: a flywheel, 2 housing pieces, an eccentric shaft, a trochoid rotor, and 4 screws. First, the housing, then put the eccentric shaft into the rotor, put the eccentric shaft and the rotor into the housing, align the back plate of the housing to the main housing piece. Secure the back plate to the housing with 4 screws. Lastly, move the rotor around to make sure that it spins freely. Our first challenge occurred when we had trouble keeping the compressed air contained in the housing. This occurred because the parts were not fitting properly. We overcame this by reprinting the housing to provide a better fit. Once it was put together, we struggled with getting the engine to spin freely. We overcame this challenge by sanding the parts down to have a smoother surface, as well as lubricating and turning the engine by hand and drill to get the engine to spin fluidly. After overcoming these challenges, the engine ran fluidly. To gauge how fast the engine ran, we reviewed the footage in slow motion to find that it was spinning at 14,400 plus RPM at 80 psi. The engine could also run at over 120 psi. In conclusion, overcoming challenges such as sealing issues and fitment between the components required perseverance and creative problem-solving skills. This project not only deepened our appreciation for past innovations, but also inspired us to continue exploring new frontiers in engineering.